Hello students, welcome to AIMS India online classes. This is a chemistry session. In this, we are studying about the chapter Language of Chemistry. So in this session, we are going to see about naming of chemical compounds. While there are many thousands of different chemical compounds, there is definite, a very definite system of nomenclature whereby we can name or write chemical formulae for most of the chemical compounds, isn't it? Yes, we came to know nowadays thousands, lakhs of chemical compounds. But for every compound, it is given a prescribed name. Unique name is given. This is because of the very definite system of nomenclature. What does it mean, nomenclature? The system or the rules by which we can name a compound. By keeping these specific rules and system for naming the compounds, we are able to name these all available chemical compounds, crores and crores of compounds. Okay. So in this learning system of nomenclature, first, let us divide these all chemical compounds into two main categories, two types. They are binary compounds and ternary compounds. Binary compounds means the compounds containing only two kinds of atoms in its molecule. Only two kinds of atoms will be there. Such kind of molecules are called binary compounds. The compounds containing only two kinds of atoms in their molecules are called binary compounds. For example, sodium chloride, NaCl, only two kinds of atoms are there in the molecule. So it comes under binary compound. On next category, second category is ternary compounds. That means the compounds containing polyatomic ions. Means there will be more than two kinds of atoms in the molecule. Out of those, there will be polyatomic ions. Poly means what? Many. So the ions with more than one atoms will be existing in these ternary compounds. The compounds in which there are polyatomic ions are called ternary compounds. For example, if I say sodium sulfate or calcium carbonate, in that there is a ion called carbonate ion. CO3 2 minus it is called. It contains more than one kind of atoms in the ion. That kind of ions are called polyatomic ion. There are totally four atoms in the ion. They are called polyatomic ions or simply radicals also they are called. So the compounds containing these polyatomic ions or radicals are called ternary compounds. So now first among these, let us see how to name these binary compounds. What does it mean binary compounds? The compound containing only two kinds of atoms. So let us learn first how to name these binary compounds. All binary compounds contain only two kinds of elements in it. The name of every binary compound ends with IDE. Yes. So every binary compound contains only two kinds of atoms, as we said. Two kinds of elements. Atoms of two elements. So every binary compound's name will be ending with IDE. For every name, it will be there at the ending IDE. Binary compounds come in three types. Again, these binary compounds are classified or segregated into three types to understand easily. Let us see those. What are those? First one, type 1. They are the metal forms only one type of cation. Yes. So the first category are the type 1 binary compounds contain metals which exhibit only one valency or which can form only one kind of cation. For example, if I say sodium chloride, in that the metal is Na, sodium. It can form Na plus ion, only one kind of positive ion or cation it will form always. Na plus. So such kind of binary compounds in which the metal exhibit only one valency are called type 1 binary compounds. Next, type 2 binary compounds. In these also there will be metal which can exhibit more than one valency or which can form two or more types of cations are called type 2 binary compounds. For example, if you see FeCl or FeCl to FeCl3 here, iron FeCl2 if I say in that there is a metal iron. which can exhibit more than one valency or which can form more than one kind of cations. They are Fe plus 2 and Fe plus 3, two ions it can form. So the compound formed by such element, such metals are coming under type 2 binary compounds. Then the third one is tertiary or type 3 binary compounds. They contain no metals in them. They contain only non-metals in them. Both will be non-metals only. They are called type 3 binary compounds. First, let us say about naming of type 1 binary compounds. What are type 1 binary compounds? The binary compounds in which there is metal which can form only one positive ion, one kind of positive ion. To say simply, the metal which can exhibit one valency. The naming of system for this type 1 compounds is quite simple and is followed like this for below. Rules for naming type 1 binary compounds. First one is the cation is always named first and then the anion second. A simple cation takes its name from the name of the element. Suppose cation means what? The positive ion. First name in the naming of these type 1 binary compounds, first cation is named. That means positive ion's name is named or metallic ion is named first. Its name is taken from the name of that element. Next, a simple anion is named by taking the first part of the element's name. And for the first part of the element's name at the ending, id is attached. Write the name for the compound by combining the names of these ions. So what are the rules given? Let us see once again. In naming the type 1 binary compounds. Type 1 binary compounds means the binary compounds which contain one metal or non-metal and that metal can exhibit only one valency. So there, first the name of the cation is written. Name of cation is taken directly from the name of the element. And then name of the anion. So the half part of the name of the element is taken into the name of anion and at the end id is attached so that we get complete name when you combine these two. Okay, let us see a simple example for this to understand easily. Name the compound calcium oxide. So here the metallic ion is calcium, non-metallic or anion is oxygen. Now what we told, first metallic ion or cation is named. What is cation here? Calcium. Calcium is a chemical symbol for Ca is a symbol for calcium. So first we write calcium into the name. Second, O represents. O is a symbol for oxygen. So from this name, first few letters are taken OX, ox, and at the end id is attached. So calcium, ox, ide. If you combine these all, put the pieces together to get the name calcium oxide. So the name of this compound is now calcium oxide. Did you understand how the name is given? First, the name of cation is written as calcium and the name of the anion from the name of the element is taken few words OX, ox. And at the end of this name, negative ion's name, id is attached. Calcium oxide. When we combine this all, we get the name as calcium oxide. In this way, it is very simple in writing the type 1 binary compound's name. Okay. Next, let us see. Name the compound Li3N. Okay, let us try to understand this by taking one more example, Li3N. What is the cation here? Li represents lithium. N represents nitrogen. So cation is from lithium, anion is from nitrogen. See here, lithium is a chemical, Li is a chemical symbol for lithium. So first we write in the name lithium. Next N. N is a chemical symbol for nitrogen. So from the name of this nitrogen, whose root is niter, NITR is taken from the name nitrogen. At the end of this anion's name, id is attached. So when we combine these all, what we get? Lithium nitride. Total it becomes lithium nitride. So in this way, in the first type binary compounds, first cation name is written and anion name is taken from its element name, and then id is attached at the end of the anion's name. Total it becomes complete compound name. Lithium nitride, here it is its chemical name. Okay, now let us see type 2 binary compounds. What are these? The compounds which are containing metal and non-metal, cation and anion, but the metal may form more than one valency or can exhibit more than one kind of cation. Now let us see here. For type 2 binary compounds, the metal present is variable valent. The naming system for this type of compounds is given as follows. In this also, let us see some rules for following this. First, the cation is always named first and then anion second, as for the first system we have given. Here also, first cation name is written and then anion name. The cation takes its name from the name of the element. In addition, as we told, the cation is variable valent here. So it includes a Roman numeral to indicate the valency of the metal on the metal cation. Yes, as this in this type of compounds, that metal may show more than one valency or more. It can form more than one kind of cation. That is why after writing the name of the cation, in bracket, a Roman numeral number is written which indicates the valency of that cation in that particular compound. It is additional from the type 1 binary compounds. Next, anion name is as usual, it is written, part of the element name is taken, and for that at the ending ID is attached, just like the previous case. Okay, for this also, write the name of the compound by combining the names of the ions. Just we combine these two now. So what is additional here than the type 1? Including the Roman numeral beside the cation name in the brackets, which indicates the valency of that variable valent element in that particular compound. Let us do an example. Name the compound FeCl2. So here iron can exhibit actually more than one valency. For that, we have to mention the Roman numeral also in addition at the bracket. Let us see that. Iron, Fe is the chemical symbol for iron. So iron we write first as a cation name. Fe is a variable valent element. So therefore a Roman numeral is needed here. To write beside iron, we have to write a Roman numeral which represents the valency of iron in this compound. First we have to find that. Chlorine is a chemical symbol, Cl. Cl is a chlorine symbol of chlorine, whose root is chlor. Add the ide at the ending of chlorine. So it becomes a chloride. So cation name is iron, anion name is chlor. At the end it is attached ide. It becomes iron chloride. But here, as iron is a variable valent element, one Roman numeral should be added at the middle. At this point, we have iron chloride. To find the Roman numeral, so here we have to find this Roman numeral, what to be written here. We know that chlorine has -1 charge. Yes, chlorine shows a -1 oxidation number or -1 valency. By the reverse process of crisscross, we can find the valency of iron in this compound as 2. Yes, we know how we write a chemical formula by using crisscross method. So if you reverse that, actually its formula is given as FeCl2. If you crisscross this, these two will come to iron as valency, and the one here written will come as the valency of chlorine. We know the valency of chlorine as 1. Now the valency of iron becomes 2 in this compound. Okay, now we found the Roman numeral will be 2. Put these pieces together to get the name iron 2 chloride. So the final name will be iron 2 chloride, which is also called as ferrous chloride, because iron can exhibit two valencies plus 2 and plus 3. In this compound, the valency of iron is plus 2, we found it as 2. So if it is lower valency, the cation name is ended with OUS. Instead of writing Roman number 2, we can write it as ferrous chloride also. Both will be same. Iron 2 chloride or ferrous chloride. Both are same. Okay, what we have done here? First we have written the cation name, which is taken from the name of that element. Next, anion's name, which is taken apart from the element's name. And id is attached at the end of the anion's name. And at the middle, we have kept a Roman number which indicates the valency of that metal in this compound. So that is identified by taking the valency of anion, and by using reverse of crisscross method, we found it as 2. By that, the name became iron 2 chloride. Okay, next. One more compound let us need to understand is the name the compound PbS2. So here the cation is of lead, anion is of sulfur. Now let us see. Pb is the chemical symbol of lead. Now cation name becomes lead. And Pb is a variable valent element. Therefore, a Roman numeral is to be found or needed. And S is sulfur, whose root is sulf. Actually, from the name sulf is taken, it can be taken often, can be written like this also, SULPH. It can be written sulfur F, by using F or PH it can be written. Now, from the root it is taken sulf. Now, at the end of this sulfur, ID is added, it becomes now sulfide. So, lead sulfide 2 came. 2 anion name, cation name both are coming now. So first we write cation name lead, and at the end we write sulfide, anion name sulfide. But at the side of this cation name, it is written a Roman numeral, which indicates the valency of that metal in the compound. That is to be found here. How can we find? Sulfur has its valency 2. We know sulfur is one of the non-metals. It exhibits a -2 charge in its compounds. So by using a crisscross reverse method, we know here for sulfur valency is 2. So by the reverse of crisscross method, we can get the valency of lead in this compound as 4. How it is? Actually for sulfur, by reversing these numbers, you should get here 4. To get it 4, sorry, it should get here 2. But here only 1 is there, no. To make it 2, we have to multiply both with 2, because as some common factor is eliminated. So it becomes 2 here. These 2 is the valency of sulfur, and this total, which is equal to 4. This is the valency of lead. Now the valency of lead is found from this crisscross reverse method as 4. So this 4 is written as the Roman numeral in between the cation name and anion name. Now the compound name becomes lead 4 sulfide. Okay, in this way type 2 binary compounds names are given. First cation name is written and next anion name is written. In between these two, a Roman numeral is written in the brackets, which represents the charge or the valency of that variable valent metal in that compound. Okay, next type 3 binary compounds. What are these type 3 binary compounds? The compounds which contain only non-metallic elements, no metals. So type 3 binary compounds contain no metal atoms, only non-metals will be there. So rules in naming these type 3 binary compounds, let us see here. First is the first element in the formula is named first. So both are non-metals only, but whatever the non-metal is being first, its name is written first. And the full element name is used. So for the first non-metal, full non-metal name is used. The second element name is named as an anion. As we have seen in the previous two cases, for the second nonmetal, half of or root of the name element name is taken, and at the end ID is attached, just like the previous cases. Prefixes are used to denote the number of atoms present. Here, especially we use prefixes. For each nonmetal, we use a prefix which represents the number of atoms of that nonmetal present in the molecule. Okay, prefix is used. The prefix mono is never used for naming the first element. Suppose as there are two nonmetals, for the first nonmetal only one nonmetal atom is existing, then need not to use mono here. For the remaining all, we use different prefixes which represent the number of atoms of that nonmetal in the molecule. Okay, only for the single monoatomic element, we don't use mono. See here, some prefixes which to be used for writing are given here. If there is only one mono, two di, three tri, tetra, penta, hexa, hepta, octa, nona, and if there are 10, deca. So these are the different prefixes used for representing the number of non-metallic elements or number of non-atoms of non-metals present in it. Okay, let us see some examples. Here it is given, name the compound NO2. If you observe, both are nonmetals here, nitrogen and oxygen, isn't it? Both are nonmetals. Now, in naming this, N is the chemical symbol of nitrogen. So, as it is in the first element, first its name is completely used. Nitrogen is written. Since there is only one nitrogen atom and it is a first element, the prefix mono is not used. Just directly we write nitrogen. Mono nitrogen is not written. If there are more than one, suppose there are two nitrogen atoms, then dinitrogen is written. But here in this compound, the first element is nitrogen and it is there only one nitrogen atom. So just we directly write as nitrogen. Let us go to next second element. Second one, O. O represents, O is the chemical symbol of oxygen, whose root is ox, and the id ending to get the oxide. So id is attached to the root of this oxygen element OX, ox. Now it becomes oxide, nitrogen oxide. But here, before oxide, some prefix to be added, because if you observe here, how many oxygen atoms are there? Two oxygen atoms. That number of oxygen atoms also will be represented by using some prefix. So if there are two, the prefix di is used. So before oxide, di is attached. Now it becomes dioxide. If we combine these all, what do we get? Nitrogen dioxide. It is the name of this NO2. Did you understand how we have written this? First, name of the first non-metal is written directly. If there is only one non-metallic atom, need not to mention anything like mono. If there are more than one, then some prefix should be added to that name of the non-metal as di, tri based upon the number of atoms. Then we have to come to second one. Name of the second, actually some root of the non-metallic element is taken for the second. Directly complete name is not written. Suppose if you see in this only, oxygen is the second non-metal, but completely oxygen is not written. Root OX, ox is only taken. For this, id is attached. So it becomes oxide. And there are two oxygen atoms. For the second element, compulsory we have to mention the number of atoms. Even it is single also. Monooxide can be written if it is there only one oxygen. As here there are two oxygen atoms, dioxide is taken. Now the total name becomes nitrogen dioxide. Okay. In the reverse, if you say write the formula of carbon tetrachloride, the chemical symbol for the carbon is C. There is no prefix before the carbon in the chemical name. Therefore, there is only one carbon atom in the chemical formula. If you see, they have given the name. In the reverse, we are trying to write the formula for this. So first, what we write? First non-metal element. What is it? Is it given carbon? We know the symbol of carbon is C, and nothing is mentioned in front of this name. It represents one carbon atom. So in the formula, there will be only one carbon atom. C should be written. Okay. Next, tetrachloride has the prefix tetra. Tetra represents four atoms, which means there are four atoms of chlorine. Chloride is derived from the chlorine, so Cl is its symbol. So chloride is derived from the symbol element name chlorine. So it has a symbol Cl. So there are four Cl atoms in the chemical formula. By that we get its name as formula as carbon C and chlorine Cl. Tetra representing four chlorine atoms. So total it becomes CCl4. Carbon tetrachloride chemical formula is CCl4. Okay. Next, naming of okay, this second category we came to know. Naming of ternary compounds. Compounds that contain polyatomic ions, nothing but radicals. A polyatomic ion is a group of atoms with an electric charge. Yes, just like the single atomic ions, polyatomic ions also exist in the chemical compounds. They are called simply radicals also, like SO4 minus to a sulfate ion, nitrate ion, carbonate ion. These all will come under polyatomic ions. The names of nearly all polyatomic ions end with the letters 8 or 8. Exception: cyanide ion, hydroxide ion, and peroxide ion. Actually, cyanide ion is a Cn minus. These are some exceptions. Actually, it is getting ide at the end name. Hydroxide also OX, OH minus oxide, and peroxide O2 minus 2. This is peroxide ion. So anyhow, these are the exceptions. These are getting ide at the name. But the remaining mostly polyatomic ions, they get either 8 or ide at the name and at the end of name. A binary compound, when you actually have a ternary compound, you may confuse if you have cyanide and so only these three are exceptions. Mostly they contain either 8 or 8 in their name. Okay, now let us see how to name these. Naming of these ternary compounds. So by following the systems which are given for type 1 and type 2 binary compounds, but do not change the name of the polyatomic ion. Generally simply follow the rules which are given for writing the names in type 1 and type 2 binary compounds. The same we write here also, we follow here also. But only there we are cutting the name of this anion. Just we have taken the root, no? So we won't do that here. Directly complete names are taken in this ternary compound naming. Let us see some examples. So this is one of the ternary compound because it is having an ion with more than one atoms in it. It is called sulfate ion. SO4 minus 2 is sulfate ion. So how do we name this? First metallic ion sodium and next directly sulfate, sodium sulfate. If you see here iron, it is nitrate ion, iron nitrate, but as its valence is being 3, it is named as iron 3 nitrate, which is also called ferric nitrate. And next it is hydroxide ion and it is calcium ion. Simply when you combine these two we get calcium hydroxide and it is nitrite ion, copper nitrite. It is ammonium, it is a dichromate, ammonium dichromate. Just by adding these two we get this name of ternary compound. It is a biphosphate ion or a dihydrogen phosphate ion. It is potassium, potassium dihydrogen phosphate. In this way, names of the ternary compounds are taken directly from the names of cation and polyatomic anion. Okay. There are some tribal names also, or common names. We have seen now naming the compounds by using some systematic rules. But some compounds they have some tribal names or common names. There are certain names of the compounds which do not follow any systematic rule. Such names are called tribal names or common names. Chemists have not considered wise to replace these names by systematic names as they are widely understood by the common man. Yes, we are using some common names or tribal names for the certain compounds. They do not follow any systematic rules. They have given those names based upon the availability or sources and based upon the properties. For certain compounds, they have given some common names. They do not have any particular rules for that naming. But scientists, they did not replace their names. They're being used till now because they are very familiar. In that way, they are understood very easily. That's why they are commonly, continually used now. Okay, next, let us see some examples of these tribal names or common names. The common name of nitrogen hydride is ammonia. We know ammonia means, but actually its chemical name becomes nitrogen hydride or nitrogen trihydride because its formula is NH3 as per the uh, type 3 binary compounds rules. First to write the name of the first non-metal nitrogen and name of the second non-metal hydr and ID is attached and the number of hydrogen atoms will be mentioned at the middle. It should be nitrogen trihydride is its name, but commonly it is called as ammonia. Ammonia is its tribal name or common name. And for the common name for the sodium chloride, we know it is very familiar compound. Sodium chloride, NaCl, has so many common names like table salt, common salt, rock salt. These are all the common names of sodium chloride. One more common name for hydrogen oxide is water. Dihydrogen oxide it is water. Common name of potassium nitrate is niter. In the same way, magnesium carbonate has a magnesite common name. This way, these are all coming under common names or tribal names. They do not have any peculiar rules for writing this. Okay. So in this way, names are given for the different kinds of compounds. Thank you for watching our video. Please subscribe our YouTube channel Aims Today for receiving latest updates on recorded videos. Thank you.